Okay, now we're going to solve radical equations. And so radical equations basically include a radical. And so those are kind of the square root, or we could be talking about a cube root, or so on. And so to solve these radical equations, if necessary, we need to arrange the terms so that the radical is isolated to one side of the equation. Okay, step two would be to raise both sides of the equation to the nth power to eliminate the isolated nth root. And so they're referring to the value of the radical right here. This is known as the index right here. So whatever that is, if we're talking about a square root or cube root or fourth root and so on, that's what we'll raise both sides to. Then we'll go ahead and solve and then check proposed solutions in the original equation. So that is actually very important. We do need to check these because sometimes we will get extraneous solutions that do not work. So right here it says solve each radical equation, check all proposed solutions. Note, square roots cannot have negative roots. Okay, that means basically we cannot have negative solutions. Now, that doesn't mean your answer can't be a negative number. It just means that your we don't want to be square rooting any negative values. So we need to be a little careful here. Okay, so right here on our first example, we're going to start out pretty simple. So we have the square root of x equals 4. So going back to that index, the n value, if there is no value there, it's understood as being a 2 because it's the most common radical that we deal with. So if there is no index listed, it's understood as 2. So what we're going to do here is we are going to square both sides. And so that will nullify the square root, and I'm left with x equals 16. And that's fairly simple to check. We should know that the square root of 16 is 4. So we're good to go on that solution. Okay, let's look at B. So we're going to do the same thing. We're going to square both sides. And so this is going to become x equals, and negative times a negative is positive, so we get 16. But in this case, it actually does not work. It does not work. So I can't include that as my solution because the square root of 16 does not equal negative 4. So this one's going to be no solution. Now, on your homework, a lot of times whenever they have no solution, a lot of times they'll tell you to type D E, or I'm sorry, DNE, which is going to stand for does not exist. So a lot of times that's the format they'll have you do on the homework. So just be aware of that. Okay, moving along. So, oops, a little too quick. There we go. Here we go. So we have the square root of y plus 7 equals 3. So once again, we'll go ahead and start by squaring both sides. And so let's see, we're going to have y plus 7 is equal to 3 squared is 9. And then we'll go ahead and subtract 7 from both sides. And so we get y equals 2. And then this is pretty simple to plug in. You can see right here if you were to plug in 2. So let's see, we're going to check. So we're going to let y equal 2. So we'd have the square root of 2 plus 7 equals 3, which is the square root of 9 equals 3, which is true. So we can stop right there. Now be careful. Your answer is 2. Y equals 2. A lot of times when we start testing it, sometimes we kind of forget. And we're like, oh, my answer's 3. Well, you're going to put that in. It's going to be counted wrong. So be careful. The actual answer is y equals 2. And so we just want to check it and make sure and everything looks good. Okay, looking at example D right here. So once again, we'll go ahead and square both sides. So we end up with y plus 2 equals negative 2 times negative 2 is positive 4. And then we'll go ahead and subtract 2 from both sides. And so we're going to get y equals 2. Okay, and we better double check that. So we're going to check. So we're going to let y equal 2. So we get the square root of 2 plus 2 equals negative 2. Okay. And so we're going to get the square root of 4 equals negative 2. Nope, that is false. That's false. So that one does not work. So no solution or does not exist. Okay, as we move forward now, these are going to get a little bit more interesting. They're actually going to turn into quadratic equations that we are going to have to solve, and we're going to get two solutions. Now, when you get two solutions, it's possible they could both work. It's possible that neither works. But most of the time, what's going to happen is one works and one does not work. So that's what we're going to run into most of the time. So looking at E right here, what we have to do, we're going to start by squaring both sides. And so this is going to become 3x plus 18 equals x squared. And so we're going to want to set up a quadratic equation here. And these should all be factorable. We're not going to have to do the quadratic formula. It's possible that those could happen, but we're going to avoid those. We shouldn't see anything like that. So I want to keep my x squared positive. So I'm going to subtract both sides by 3x and by 18. And so that's going to zero out my left side. So I'm going to have 0 equals x squared minus 3x minus 18. Okay, so just kind of review what I did. I squared both sides, it nullified the square root, and then I ended up having an x squared. And so that goes back to one of our first lessons. Whenever you have x squared, you want to go ahead and put it in standard form. You want to set it equal to 0. Now, if you wanted to do the quadratic formula, you could, but like I said, these should all be factorable, and factoring is typically going to be the easiest process if it's available. So I have to go ahead and figure out, okay, what I'm going to do the A&M method. I have to figure out what multiplies to give me negative 18 but add up to negative 3. And that should be a minus 6 and a positive 3. Those two numbers multiply to give me negative 18. Those two numbers add to negative 3. So then we'll take each one of those because we want to figure out, okay, what would make that equal 0, the first factor, and the second factor, because if either one of those factors is 0, it would multiply together and become 0. So we'll go ahead and add 6 here. And so we're going to get x equals 6. That's one of my possible solutions. And then over here, I'm going to subtract 3 on both sides. I'm going to get x equals negative 3. Now, like I said, most of the time what's going to happen is one will work and one will not work. So we have to come over here and check them. Okay, so we'll start with x equals 6. So let's see, that would become, so I got to plug that in everywhere I see x to see if it's true. So, and it has to be plugged into the original before any manipulations have been made. Okay, so we're checking this to see if this is true. So let's see, 3 times 6, let's see, that's 18. So 18 plus 18 would become the square root of 36. Square root of 36 indeed does equal 6. So that is true. Now be careful. Once again, my answer over here is 6. I guess it's the same, so that's okay. Let's try negative 3 now. X equals negative 3. So I have to plug that in everywhere I see x. So we'll place it right there, and then plus 18 equals negative 3. Now alarm bells should be going off right now because the square root is not going to equal a negative value right here, negative 3. But I'm going to go ahead and continue just so we can see this. But right here, let's see, that's going to give us negative 9 plus 18, which gives us the square root of 9, which does not equal negative 3. That is false. So what that means is we can't use that as part of my solution set. And if you do, it's going to get counted wrong. So you want to make sure you don't do that. All right, moving on. This one's going to be kind of similar. To start though, we got to be a little careful right here. So we're going to square both sides right here because the radical is isolated. Now, this will become x plus 3 right here. Now, the right side, there's a very common mistake students make here, and that is that they think it's just x squared minus 3 squared, and that is incorrect. You can't do that. Okay? So let's kind of review what happens when you square something. Let's just be real basic. Well, what is 5 squared? Well, you're going to say 25, but why? Because it's 5 times 5. 5 times 5 is 25, right? So right here with x minus 3, well, that's really x minus 3 times x minus 3. And we have to go ahead and FOIL that. So let's see, we have the x plus 3 still right here. And then when we FOIL this, so we multiply that term by the first two over here, so that gives us x squared and then a minus 3x. Then we have to multiply the minus 3 by both of these, so that gives me another minus 3x, and then negative 3 times negative 3 is a plus 9. And then we're going to go ahead and consolidate these like terms right here. So let's see what we have here. X plus 3 equals x squared minus 6x plus 9. Now, just like the previous one, we want to go ahead and put this in standard form. So what I'm going to do is I got to subtract an x here, and I'm going to subtract 3 here. And so we'll 0 that out. So 0 equals x squared. This becomes minus 7x. This becomes plus 6. And now we'll go ahead and factor this. So let's see, it should be a minus 6 and a minus 1, because those multiply to give me a positive 6, but they add to give me that minus 7x in the middle right there. So then we take each factor and set those equal to 0. And so I'm getting possible solutions of 6 and 1. All right, so then now I need to go ahead and check that. So let's see, when x equals 6, let's see, so I'll have the square root of 6 plus 3. Does that equal 6 minus 3? So I'm just plugging it in where you see x. Put a little question mark here. Well, let's see, we end up with the square root of 9 equals 3, which is true. Once you recognize it's true, you can just go ahead and stop, and that looks good. Now let's test the other one just to be sure, because like I said, it is possible they could both work. It doesn't happen very often, but it can. So let's see, we're going to have 1 plus 3 equals 1 minus 3. So we're going to get the square root of 4 equals negative 2. Well, my square root's not going to equal negative, so I'll go ahead and put false. And so that one cannot work. And so we only want to include 6 right here. And once again, be careful. The solution is 6, because like I said, sometimes you get down to this point, you kind of forget about what you're actually doing. So we figured out that 6 is the value that when you plug it in, it is a true statement. It makes the equation balanced. All right, here's another one. Should be pretty similar to what we've been doing. So once again, we'll go ahead and square both sides. And once again, you're going to need to break this into x plus 8 times x plus 8 equals, and then this is going to be 2x plus 19. And we'll FOIL this together. And so what's going to happen is x times x, that's x squared. Then you're going to get 8x plus 8x. So I'm just going to go ahead and combine that together now to 16x, right? Because you get 8x twice. And then 8 times 8 is 64. And then equals 2x plus 19. And then once again, we need to set this equal to 0. So I'm going to subtract 2x from both sides and subtract 19 from both sides. That leaves me with x squared plus 14x. And then let's see, what is that going to give us? Plus 45 equals 0. And now it's time to play our little game, figure out what multiplies to give me 45 but add up to 14. And I believe it's going to be 9 and 5. 9 times 5 is 45. And 9 plus 5 is 14 right there. So let's see. So my two possible solutions would be -9 and -5. So You'll notice I kind of skipped a couple steps. I'm assuming y'all are getting pretty good at this now. You just set this equal to 0 and solve, and I just kind of did that in my head. So those are my two possible solutions, but now it's time to check them. So x equals -9. I got to plug that in here and here. So I'm going to get -9 plus 8 is equal to the square root of 2 times -9 plus 19. And then once again, I'm kind of asking myself, is this true? Well, right away, there's going to be an issue here because this adds up to -1 and my square root is not going to equal a negative value. But we'll go ahead and keep going for a moment. So let's see, that's going to give me the square root of -18 plus 19. So I get -1 is equal to the square root of +1, which is false. So I know that that is not going to work. Now we're going to try x equals -5. So let's see, -5 plus 8 equals the square root of 2 times -5 plus 19. And then let's see, -5 plus 8 is 3 equals the square root of -10 plus 19. So we end up with 3 equals the square root of 9. Yes, that is true. So we know -5 is a solution. Okay, continuing, let's see, we've got another one here. So let's see, we're going to go ahead and square both sides to get started. So we're going to have x plus 5 equals, and then remember I got to break this apart as x plus 5 times x plus 5. So a lot of x plus 5s. Okay, so I need to FOIL this. And so x times x is x squared, then x times 5, and then 5 times x. That's a total of 10 x's. And then 5 times 5 is 25. Now it's time to set this equal to 0. So let's see, we're going to go ahead and subtract x from both sides and subtract 5 from both sides. So that zeroes out the left side. And then the right side, I'm left with x squared plus 9x and then plus 20. Okay, and so now we'll go ahead and factor this. So doing the A&M method, figure out what multiplies to give you 20, but then those numbers add up to 9. And that's going to be 5 and 4. So 5 times 4 is 20. Those add together to give you 9. And then now you're trying to figure out what makes each factor equal 0. Well, this one is going to be -5. And this one's going to be -4. Those are the two values that make each individual parentheses equal 0, which would cause the whole thing to zero out. So now we need to check these. So we'll start with x equals -5. Well, let's see. We're going to get the square root of -5 plus 5 equals -5 plus 5. Well, this is going to become the square root of 0, which equals 0, which, yeah, actually that is true because 0 times 0 is 0. So, yes, this is true. So, -5 is a solution. Be careful. -5, not 0. -5 is the value that we plugged in, which made the equation true. Now, what about x equals -4? So now it's time to plug that in there. So let's see, the square root of -4 plus 5. Does that equal -4 plus 5? Well, let's see, the square root of this, let's see, this would simplify into the square root of 1. This simplifies to a 1, which, yes, that is true. That is a true statement. So in this particular example, they actually both worked. So we actually had two solutions that would make this equation true. Okay, that won't happen very often. Most of the time, it'll only be one that works, but in this example, we got to see one where they both work. Okay, so we've only focused on square roots. We're going to look at cube roots a little bit. Okay, we're just going to do a few of those. So it says solve each radical equation. Note, cube roots can have positive or negative roots. So that means that we can actually cube root negative numbers. Okay, with the square roots, you can square root a negative, but then you get those imaginary solutions. But with cubes, it's okay to cube root negative numbers. Therefore, all solutions found work. So here you don't even have to check your solutions. You can if you want, but it's not going to be necessary. So on this first example, I have the cube root of x. And so to nullify the cube root, I'm going to cube both sides. So I'm going to end up with x equals 2 to the third power, which is 8. 2 times 2 times 2. If you want to plug it in, you can. It does work. Example B, pretty similar. What we're going to do here is we're going to cube both sides. Now you have to be careful here. This time you're going to have negative 2 times a negative 2 times a negative 2. So you're actually going to get negative 8 as your answer, and that's okay. It does work because you can cube root negative 8. You can cube root negative 8, and it does equal negative 2. Okay, our last example, we actually didn't have to do this on any of the square roots, but you have to isolate the radical. So anything that's not part of the radical, you actually need to move to the other side of the equation. So what I need to do on example C is I need to add 3 to both sides to get started. So then I'm left with the cube root of 8x plus 1 equals negative 2. And so then now I'm ready to cube both sides. So I'm going to cube both sides. So cube, cube. And so then that will nullify the cube root, and I'm left with 8x plus 1 equals negative 2 to the third power is negative 8. And then we're going to go ahead and solve this. So I've got to subtract 1 from both sides. So let's see, we get 8x equals negative 9. And then we're going to go ahead and divide by 8 on both sides. Okay. And so then let's see what I end up with. X equals negative 9 over 8. And as long as you feel like you did your algebra correctly, you don't really have to worry about checking it. I'll show it to you just so you can see. So let's see, the cube root of 8 times negative 9 over 8 plus 1, take away 3. Does that equal negative 5? Well, what happens here is the 8's will cancel out, and so then I'm left with the cube root of negative 9 plus 1, take away 3, equals negative 5. And then this would simplify into the cube root of negative 8. And that's okay. We can take odd roots of negative numbers. If it's an odd root, if this is odd, then you can actually pull the negative on the outside and kind of just focus on taking the cube root if you want. You don't have to, but sometimes I just say, get it out of the way. If it's an odd root, just pull it out so you can focus on this part of the process. And so the cube root of 8 is going to be 2, but you don't want to forget about the negative that was pulled out. So negative 2 minus 3 does equal negative 5. So you can see it works. Now, like I said, whenever you're dealing with the odd ones, you really don't have to check your solutions, but just figure it'd be worth practicing some of our algebra here. Okay, that's it for this. If you have any questions or concerns, let me know.